meters is 6 quarter wavelengths. I know, what is it? It's 0.32 times 4 divided by 6. 0.21333333333. And I'm just going to write an exact value down there, even though the sig figs aren't working out so well, right? Okay, because I want to use the exact value on this, right? And then now we want to figure out frequency. If you recall, for frequency, we frequently, where's my red pen? Oh, there it is. Okay, for frequency, what we're going to use is this formula. V is F lambda, right? Isn't frequency always V over lambda? Isn't it? Right? And this makes sense because the smaller lambda is, the more frequently it has to go by, right? Huh? Okay. So for this guy, the speed is 281.6 meters per second is equal to the frequency times 0.64 meters. How many of those have to go by? Well, yeah, it's 440, isn't it? Right? Is that a frequency of a violin string? Yeah, that's an A, isn't it? So this is the second string down. It's not the highest string the violin plays. It's the second one down. It was a long time before I figured that out. Right? It's like, oh, it's not the high string. It's the next one, right? Okay, so this guy here is half the wavelength. Any guess what its frequency is going to be? It's going to be twice the frequency. Half the wavelength, twice the frequency. Right? Let's write it out anyway. So 281.6 meters per second is F times 0.32. And so 281.6 divided by 0.32 is 880 hertz. All right. What's this one? Is this going to be 1760? Is it going to keep doubling? Is that the pattern, or is it going to keep adding 440? Yeah, let's just see, right? Okay, so 281.6 meters per second is F times 0.21333333333, right? So 281.6 divided by, it's 1320, isn't it? So the pattern is what? Well, it adds. It always adds, right, or something like that, right? Okay. The pattern is, if this is the fundamental, right, this is 1 times the fundamental, right? This is 2 times the fundamental. This is 3 times the fundamental. Yeah? Now, here's a cool thing. Here's a cool thing. I can play this on my guitar. Why, I happen to have my guitar in here. And I can play this on my guitar, which is, by the way, tuned down a whole step. So here is this is the fundamental, right? That's this guy here. I'm just going to pluck the string right in its center. Right there it is. It has more overtones if I pluck it near the edge. It sounds more fun. Now, if I want to force the second harmonic, if I want to force that, what I do is I put my finger lightly on the string. I don't press it down against the frets. I just hold it lightly on the string at this point to force a node there. Right? This is called playing harmonics, right? And I do it halfway down the string, which, not coincidentally, is the 12th fret, because a whole octave divides the scale into 12 equal parts, right? What interval is that? What musical interval is that? My Sharona, you make my motor run. There we go. That's an octave, and that's the joke. Is I used to use my Sharona to remember an octave. You don't need any trick to remember an octave. But like, you know, like a twinkle, twinkle, little star. That's a 5th. Twinkle, twinkle, right? And then here comes the bride. That's a 4th, right? You know, all these things, right? So I used to, when I was singing in the choir, they go, "What interval is that?" And I go, da 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 da. It's an octave. How would I get this one? Where do I put my finger on this one? A third of the way down, or a third of the way down, right? So it's like, I can also get one here. There must be one here. This is the other third, yeah? Now listen to that interval. What's this interval here? That's a fifth. Twinkle, twinkle, little star is a fifth, right? And then listen to this interval. Here comes the bride. That's a fourth, right? Then, and then then it's like my finger lacks the ability to do any finer. Right? So these notes are the fundamental basis of all harmony. Right? This is the overtone series. They underlie all of the chord structures. They are why, when you play in harmony and in tune, right, why it sounds good, because there's a mathematical relationship, and we'll get into that next time. Just remember, though, this series of intervals. Right? And I can't keep going. I can on the penny whistle, though. We'll plug your ears for that. Okay. A little applause for the... Okay, so the next thing to do is let's do a pipe, and by a pipe we're talking about this guy, right? Could also be, by the way, a trumpet, right? Although I don't think trumpets play this. I think they play, actually, this is the lowest note they do, right? I don't know. But here's the way to check. Did anybody play brass instruments? Right, play the lowest note, then play the next note up you can play. If it's an octave, then you are going fundamental, right? First harmonic, second harmonic. If you play the lowest note and then you play the next note up that you can with the same fingering, right, or same slide or same length, right, and it plays a fifth, then you're going from this one to this one, right? And again, we're going to look at that exactly next time. But now, for now, let's draw this picture. Put this in your notes so you've got it, right? So draw 3 pipes. Draw them all the same length. Yeah? And then this guy, remember this guy's got a node right in the middle. This guy's got a node a quarter of the way, a quarter of the way. This one's got a node in the middle. 1/6 of the way, 1/6 of the way. Right, this guy's got... This guy's got... That one kind of sucked, but that's all right. And then this pipe is 1.715 meters long. I picked that number not randomly. The velocity, we're going to use the speed of sound. Now, it's not a really good assumption that sound travels 343 meters per second down a little narrow pipe like this. I think it goes a little slower. Okay? Ray, this is not a good time to take a nap. This is a good time to write detailed notes. Yeah? Write it all down. Ray. Okay, so how many quarter wavelengths is this? It's 2 quarter, right? So 1.715 is 2 quarter wavelengths, right? How about here? How many quarters here? 4 quarters. Is it the same thing? There we go, right? 1.715 is 4 quarter wavelengths. Any guesses what this one's going to be?
1.715
6 quarters, same exact thing, right? So this has the same geometry as this one. It's going to have the same series of overtones, and I'm going to play them for you. 6 quarter wavelength, right? So now I can figure this out, and of course I've picked very strategic numbers here, right? So 1.715 times 4 divided by 2. Why, that's 3.43. A very convenient number, right? So lambda equals 3.43 meters. Well, gee, what's 343 divided by 3.43? Is it 100?
Yep.
There we go. Yeah. He said 10. All right. Okay. So this guy's going to be, well, it's 1.715, right? And then this guy is going to be 1.715 times 4 divided by 6. Hey, Alan! That's 1.143.